Guys, the question number 6 for you is, at a height of 3r by 8, where r is the radius of Earth, above the surface of Earth, what is the value of g? Arnav?
So see, in this question everyone knows the formula. G dash is equivalent to g 1 minus 2h upon r. So it's a very simple question, just put in the value of h from here.
Right.
G 1 minus 2 into 3r upon 8 into r.
Yeah.
So this comes out to be g upon 4. This thing will get cancelled off over here. 4 minus 3, 1, g upon 4. So the correct option is A. But this is the incorrect option. See, the trick over here is that this formula is valid only when h is less than r. Only when this term is very, very less than r, then only this formula is valid. Whereas in this thing it is almost half of r. So for this we'll have to go into the derivation. See, g dash is equivalent to g 1 plus h upon r whole square. So this thing comes over here as minus 2 and this r is very small. But in this case, having a very big value. So we'll have to use this formula itself. It will come out to be g 1 plus 3r upon 8 into r. So this will be cancelled off whole square. So 8 plus 3, 11. So 121 upon 64. 64g upon 121. So this is the correct option.
So C would be the correct option.
Yep, C would
so
be
can you write the general formula for us, guys?
See, this is only the formula. This is the formula that everyone has to use, and we have to use this formula when r is very small compared to, when h is very small compared to capital R. So this is the formula that you have to remember. Just remember this thing and remember how this thing is derived. Because if you go on doing it this way, so you might get an incorrect option, and that is generally the first option. So that in a hurry you will get this answer and you will put this. So just keep in mind that this formula has to be used only when h is very, very small compared to r.
So guys, one thing you need to remember is if h is marginally less than r, you have to use this formula. If it's comparable to r,
then we have to use this formula.
Yep. Okay, right. Let's move on to the next question now. Let's have a look at the 7th question, guys. How much deep inside the earth should a man go so that his weight becomes 1/4 of that at a point which is at a height r above the surface of earth? Arnav?
See, इसमें सबसे पहले हमें निकालना पड़ेगा that at a height h above the surface of earth, what will be the force? So in this, because r is very comparable to capital R, right? It is comparable to that thing. So we'll have to use this formula, g upon 1 plus h upon r whole square. Okay.
Right.
So g dash. So this would come out to be g upon 1 plus 1 whole square equal to g upon 4. तो इससे हमें आ गया कि हमें g की वैल्यू this g dash should be equivalent to g by 4 का 1/4. Because in the question it is written his weight becomes 1/4 of that. So the weight has to be g upon 16.
Right.
Inside the earth. तो अभी
that
हमें
is what we want here.
Yeah, that is what we want over here. So इसका अभी दूसरा फॉर्मूला यूज करेंगे हम. g dash is equivalent to g into 1 minus d upon r, where d is the depth. So एक चीज जो इसमें ध्यान रखने वाली है that this d is applicable for anything. जैसे पहले क्वेश्चन में था that h has to be very, very small compared to r. In this d can be anything. It can be as big as r also. मतलब कुछ भी वैल्यू हो सकता है. इसका डेरिवेशन से you'll have a better idea why it is so.
So for a point inside the earth, it doesn't matter if it's marginally less or not.
It does not matter at all. So g is equivalent to 1 minus g dash is equal to g upon 16. So 1 minus d upon r. So this thing will get cancelled off from here. So d upon r comes out to be 1 minus 1 upon 16 is equivalent to 15 upon 16. So therefore d is equal to 15 upon 16 r. So this is the correct option, which is equivalent to option number B.
Okay. Let's move on to the next question, guys. So let's solve the 8th question now. We have a geostationary satellite that is orbiting around the Earth in a circular orbit of radius 36,000 kilometers. Then the time period of a spy satellite orbiting a few hundred kilometers above the Earth's surface will approximately be, or now?
Okay. See, this is again a very easy question and it has come in JEE. So you know that in JEE also they ask pretty easy questions. तो इसमें सबसे पहले तो geostationary satellite का time period दिया. So we'll be using the basic formula for any circular motion का.
Right.
So this will be equal to G m upon r square.
So basically centripetal force equal to
centripetal force is equal to gravitational force. तो इससे हमारा velocity आ जाएगा, velocity का function G m upon r. Yes, r will get cancelled off. And now time period is equal to 2 pi upon omega.
Correct.
So 2 pi r upon velocity equal to 2 pi under root r cube upon g m. अभी क्या करना है कि दो हमें इंफॉर्मेशन दिया हुआ है कि सबसे पहले जियोस्टेशनरी सैटेलाइट का टाइम पीरियड it is equivalent to 24 hours. So you have to find the time period of another spy satellite. उसका radius is approximately equivalent to 6400 kilometers. क्योंकि few 100 kilometers है, so we'll neglect that 100 kilometer.
Right.
तो इससे हमारा आ जाएगा time period. So we'll use unitary method. It is pretty straightforward. 24 hours is equal to 2 pi upon, over here it is given as 36,000.
Right.
36 1 2 3 whole cube upon gm. And this x, let's call the time period as x, is equivalent to 2 pi under root 6400 whole cube upon gm.
Right.
So we'll just divide the two of them. So 24 upon x will be equal to 360 upon 64 whole cube.
Right.
So इसको cancel करेंगे हम. This is actually the most difficult part, if you could say that, कि इसको cancel करना exam में is a little time consuming and you might go a little wrong over there.
And this is actually the place where a lot of people make silly mistakes while calculating, cancelling values.
Yep. So पहले we'll divide it by 4, 9, sorry 4. See,
16.
I also did a silly mistake. 16 will come over here, 90 will come over here.
Right.
तो इसको अभी लिख देंगे हम. X is equal to 24 into 16 upon 90 to the power of 3 upon 2.
Right.
Okay. So now this इसका under root ले लेंगे हम 24 into 4 into 4 into 4 and this thing is 90. So we don't know, like 90 का under root will come between 9 and 10. So let us take it to be 10 ताकि हमारा simplify हो जाए and then we look at the options and get the correct answer. So this is 10 into 10 into 10. So हमें एक चीज़ यहाँ पे ध्यान रखनी है कि this thing will be less than 10. Because it will be 9 point something. So therefore the whole answer should be greater than what we are calculating right now.
Exactly. Slightly more than
this. Yeah. So now we have to do this calculation. ये थोड़ा सा मतलब गंदा part है. I've done it already. 1536 upon 1000, which is equivalent to 1.536 hours. Okay. So now this is what we are getting with 1000 with taking the value 10. तो अभी हमें सारे options देखना पड़ेगा. Option में 0.5 obviously incorrect, 1 obviously incorrect, 2 and 4. तो हमारा क्या निकाला था हमने कि दिस शुड बी ग्रेटर देन 1.5. सो 1.5 से ज्यादा बड़ा जो पास में आ रहा है दैट इज इक्वल टू 2. सो दिस इज ओनली द करेक्ट ऑप्शन. सो दिस इज द वे दैट यू हैव टू डू. लाइक एग्जाम में यू हैव टू डू सम अप्रोक्सीमेशन बिकॉज विदाउट अ कैलकुलेटर 90 का ये वाला पार्ट हम निकाल ही नहीं सकते. तो ऐसे अप्रोक्सीमेट करो 10. डोंट टेक 9 ओवर. 9 वुड बी वेरी डिफिकल्ट टू कैलकुलेट डाउन हियर. ऐसे कर लो एंड चेक द ऑप्शंस.
So guys, smart approximation is one other thing we have learned in this question.
Yeah. And this is a JEE question. So like this is what they ask and they expect you to know.
Right. So we'll move on to the next question now. Let's solve the ninth question now. A satellite of mass m is moving in a circular orbit of radius r above the surface of the planet which has a mass m and radius r. The amount of work done to shift the satellite to a higher orbit of radius 2r would be Arnav.
Okay. See, first of all, इसमें they have given us that it is above the surface at a radius of r. So therefore, the distance from the center would be equivalent to 2r.
Right.
So this is the first information that we have. So we will find the potential energy at this point, that is 2r. This will come out to be minus gmm upon 2r.
Correct.
So we know that the total energy is equivalent to potential energy upon 2. So with this you can find the total energy.
U being the potential energy.
Yeah, U being the potential energy.
Okay.
So therefore the total energy is equivalent to minus gmm upon 4r. I call it total energy 1.
Right.
अभी इसके बाद they have given us in the question that the amount of work done to shift the satellite to a higher orbit of radius 2r. That is the distance from the center would be 3r.
Right.
So we'll find the potential energy again. This will come out to be minus gmm upon 3r. The energy would come out to be minus gmm upon 6r. So this is equivalent to E2 and this is equivalent to E1. So now it becomes very easy. The change in energy would be equal to E2 minus E1.
Right.
So this would be E2 minus E1, that is minus gmm upon 6r minus gmm upon 4r. So this would come out to be, there will be a positive sign over here, take LCM, minus come out to be plus gmm upon 12r. Okay,
right.
I will multiply another r over here in the numerator and denominator. See, the answer is given in terms of small g.
Right.
So we know that small g is the gravitation at the surface of Earth. So mg would be equal to gmm upon r square. That's why I put in another here. This would be this. So therefore gmm upon r square, gm upon r square would be equivalent to small m into g into r upon 12. So this would be our final answer.
Correct.
Option number B.
So guys, one thing you need to remember is sometimes when you're working out a solution to a problem, you might not be using the same terms as the question is. So you have to work out in the end, you have to see what variables are the options using.
You might have to convert a little bit in the end.
Right. So you have to use the proper correlations and all. So we'll move on to the next question.
Yep.
So guys, we have a very interesting question number 10 for you. There's a crater of depth r by 100 on the surface of moon, which has a radius r. A projectile is fired vertically upwards from the crater with velocity that is equal to the escape velocity v from the surface of the moon. You have to find the maximum height attained by the projectile. Enough?
Okay. See, first of all, it looks a little difficult. It seems very tricky. So we'll begin with whatever we know in the beginning. Okay.
Right.
So, सबसे पहले तो we need to know what is the escape velocity. Over here, let us take it to be VE. That is V escape. See, half V escape is equivalent to half mv square will be equal to g m upon r. That is, the kinetic energy should be equivalent to the maximum potential energy. So half mv square, sorry, my bad. So इससे we'll get V escape as 2gm upon r. So this is equivalent to the escape velocity at moon. I hope that this thing will also be covered in the theory. So it is fine. Okay, so now we have the V escape. Now the question is that at a depth of r by 100, a projectile is fired. So it is basically an energy equation. So at depth, okay, you have to find the initial energy and the final energy.
Correct.
So the initial potential energy plus kinetic energy should be equivalent to the final potential energy plus the final kinetic energy.
Correct.
ठीक है, तो we have to find, पूछा क्या क्वेश्चन में, find the maximum height. So the final potential energy में velocity will be equal to 0 because you need to maximize this.
Correct.
This will come out to be 0. Now we'll just plug in the formulas. For a sphere, for a solid sphere, the potential energy is minus gmm upon 2r cube 3r square minus r square, where r is the distance from the center and capital R is the radius of the sphere, plus kinetic energy half m into ve square. This is equal to potential energy in the end. So minus gmm upon r.
Right.
Let's call it as x. Okay. X is the distance, the maximum height attained.
Okay.
So now this is a very simple question. We have narrowed it down. We have written the equations and all. So we just have to solve it now. So ठीक है, let's solve it. R over here would be 99 r upon 100 because the depth is r upon 100. So the distance from the center would be 99 r upon 100.
Correct.
So we'll begin minus gmm upon 2r cube into 3r square minus 99 square upon 100 square into r square plus half m into ve. Okay. I'll put in the values of ve also.
Right.
2gm upon r equal to minus gmm upon x. So many of them, there would be a m also over here because it is a small m. Okay, this is the potential, and when you multiply it by small m, you'll get the energy. Right. So now I'll cancel off the constant terms. gmm r would come over here. I'll simplify a little bit and I'll write it down for you. This would come out to be minus plus half minus 99. No, it won't be like this. It will be minus 3 upon 2 plus 99 square upon 100 square into 2 plus 1, because this will get cancelled. Will be equivalent to minus r upon x. Okay. We are taking this over here, we cancel this, r will get cancelled off. So this would finally come out to be minus half. I'm multiplying minus sign on both sides, so it will come out to be half minus 99 square upon 2 into 100 square will be equivalent to r upon x.
Right.
This is what we get. Now we'll again have to like solve it. This again becomes a little tricky part. We have to estimate a little bit. So I'll tell you how to do that. Take the 2 over there. It will come out to be 100 square minus 99 square upon 100 square is equal to 2r upon x. Okay. So we'll use a square minus b square is equal to a plus b plus a minus b. So a plus b is equal to 199.
Right.
And a minus b will be equal to 1 upon 100 square will be equal to 2r upon x. So now this 199 we'll have to approximate it because it will come in the denominator and we won't be able to multiply it. So take it as 200. Okay. 200. So this will come out to be 100. This will get cancelled over here. So therefore x comes out to be 100r. So this is the final answer. And in the question they have asked us find the maximum height attained. So height would be we'll have to reduce the radius from this. So therefore the total answer would be 99r. Okay.
Right.
And this is using a very small approximation over here. And if you check the actual answer, if you use the calculator and all, it will come out to be 99.5r. There's just an error of 0.5. So this is a very valid approximation that we are doing over here.
All right.
So this is the final answer.
But don't you think 99r is a lot bigger value than...
No, it is fine actually, because see, the difference in potential energy in the beginning is only because like this is the sphere over here. We are instead of firing it from here, we're firing it from r upon 100.
Right.
So if you would have fired it from here, it would have gone up till infinity. So over here, it will be a little less than that. So for all practical purposes, when the r is in the denominator, 99 can be approximated to like it will be a very very small value, 0.01 when it comes in the denominator. So the answer is also logical.
Okay. So we'll move on to the next question now.